day, students! On behalf of your teachers in Mathematics 8, I welcome you all to our session on linear equations in two variables. For today's lesson, we shall be focusing on four competencies, namely the rectangular coordinate system, linear equations in two variables, the slope of a line, and the graph of a linear equation in two variables. Let's start with the rectangular coordinate system. The rectangular coordinate system, also known as the Cartesian coordinate system, is a system used to graph number pairs. It makes use of the Cartesian coordinate plane, a plane which was developed and which is named after Rene Descartes, a French mathematician who is known as the father of modern geometry. If you want to know more about the history or the development of the rectangular coordinate plane, there's a link below. Click it. The rectangular coordinate plane is composed of two axes. The horizontal number line is the x-axis, while the vertical number line is known as the y-axis. The intersection of the x-axis and the y-axis, this point here, is what we call the point of origin, or simply the origin. Since the two axes intersected, there are four regions that were formed. We have here the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. The four regions, which we call quadrants, are named in a counterclockwise direction and makes use of the Roman numeral system. Up next, take note that all numbers going to the right and going up the origin are positive, whereas numbers to the left of the origin and going down the origin are negative. The numbers we see along the x and y axis are in Hindu-Arabic form. Take note that when constructing the rectangular coordinate plane, calibration is very important. When we say we calibrate, it means that we are going to divide our number lines into practical or appropriate distances. For example, when we calibrate the x-axis and the distance from 0 to this point is 1 unit, therefore, the distance from this point to the point immediately after that should also be 1 unit. So, the distances from every point going to the right of the x-axis is 1 unit each. That should also be the case when we calibrate the left side of our x-axis. There should also be 1 unit each in every point or between 2 points when we go to the left of the x-axis. Let's have an example. Let this be 1. Therefore, the next unit should be 2, followed by 3, 4, and 5. All of these numbers are positive since we are going to the right of the origin. Next, when we move to the left of the origin, this should be -1. Why is it negative? Because we are moving to the left of the origin, followed by -2, -3, -4, -5, -6, and so on. The arrowheads mean that we can extend infinitely to the right or to the left. But what if 1 unit distances from every point is not practical? Can we have 5 units from the origin to this point? Yes. Therefore, we are going to number the x-axis in this manner. 5, 10, 15, 20, 25, and 30. To the left of the origin, we shall be having -5, -10, -15, -20, -25, and -30. This time, let's do the calibration along our y-axis. So, the distance, again, from between 2 points should be equal when we go up the origin and when we go down the origin. So, if we have here 1, above that is 2, followed by 3, 4, and so on. Going down the point of origin, -1, -2, -3, -4, -5, and so on. Is it necessary that the calibration along the x-axis is the same with the calibration along the y-axis? The answer is no. As long as the calibration to the right of the origin is the same to the calibration to the left of the origin, and going up and down the origin, that is what is important. Check this out. What you were told about the rectangular coordinate system? Again, it's a system of graphing number pairs. These pairs of numbers are what we call coordinates. Coordinates are actually the location of a point in our rectangular coordinate plane. It's simply the address of the point in the plane. This pair of numbers is an ordered pair. Ordered because the first number is for the number along the x-axis, followed by the number along the y-axis. Remember the order: x first, followed by the y. The x-coordinate is what we call the abscissa. The y-coordinate, on the other hand, is what we call the ordinate. Let us now plot the following points. Let's start with point A. The coordinates of point A are -3, 3. Take note, I did not say -3 and 3. I just said -3, 3. -3 is the number along the x-axis, while 3 is the number along the y-axis. So let's locate these numbers. -3 along the x-axis and 3 along the y-axis. Now, where is the point located? We are going to find out the point of intersection of these two numbers, and they intersected at this point. Therefore, that is the location of point A, whose coordinates are -3, 3. Next, what about point B, which is located at 2, -1? Again, we're going to look or locate 2 along the x-axis and -1 along the y-axis. Then, let us have the intersection of those numbers. The intersection of the two numbers is the location of point B in the Cartesian plane. The coordinates of point B are 2, -1. Next, let's move on to point C. It's located at 1, 4. 1 along the x-axis is this. 4 along the y-axis is this one. Now, let's find out where the intersection of these two numbers is. This is their intersection, and that is the location of point C, whose coordinates are 1, 4. Let's move on to point D. Point D is at -2, 0. Locate -2 along the x-axis, and 0, the second coordinate, or the y-coordinate, or the ordinate, means we do not move up nor down. Therefore, point D is not a point which is found in the quadrants. It is a point which is located along the x-axis. The negative x-axis, more specifically. Again, the coordinates of point D are -2, 0. This time, let us plot point E. Point E's location is 0, -2. Since 0 is the first number, or our x-coordinate, or the abscissa, it means that we do not move to the right or to the left of the point of origin. We are going to stay here. -2, our ordinate, means we are going to move 2 units down the origin. So, that would be -1, -2. Here is where point E, 0, -2, is located. Let's now plot point F, which is located at -4, -3. -4 along the x-axis, -3 along the y-axis. Again, we are going to find out where they intersect. The point of intersection is the location of point F. Its coordinates are -4, -3. And lastly, point G. Its coordinates are 0, 0. For you, where's the location of point G? Point G is actually the point of origin. Therefore, the coordinates of the point of origin are 0, 0. Let's do it the other way this time. Instead of us plotting the points in the Cartesian plane, we are now going to give the coordinates of the points that have already been plotted in our Cartesian plane. Let's start with point H. Point H is plotted or located here. Its coordinates are 5, -4. Why is it so? 5 is the number along the x-axis where the point is aligned to. -4, on the other hand, is the number along the y-axis where the point is aligned to. Remember, we always start with the x-coordinate followed by the y-coordinate. Let's move on to point I. Point I is located here. Its coordinates are, locate the number along the x-axis where that point is aligned to. that is the number -5, and the number along the y-axis where it is aligned to, that is the number 2. Therefore, the coordinates of point I are -5, 2. And lastly, what about point J? Let's find out where point J is. Point J is here. It is a point which is located exactly on the x-axis. Its coordinates are the point on the x-axis, 4, and since it did not move up or down the x-axis, its y-coordinate is 0. The location of point G is 4, 0. Did you observe something about the points we have plotted and named in the Cartesian plane? Take note of this. Both the abscissa and the ordinate of all the points located in the first quadrant are positive. Positive abscissa and positive ordinate. In the second quadrant, on the other hand, the abscissas of the points are negative, while their ordinates are positive. In the third quadrant, both the abscissa and the ordinate are negative. And in the fourth quadrant, the abscissa is positive, while the ordinate is negative. All points located along the x-axis have 0 ordinates, while all points located along the y-axis have 0 abscissa. And lastly, the point of origin is always located at 0, 0.